Welcome to the EDC IIC activity, which is Institute Innovation Council. We are bringing today one more speaker, which can tell you ABCD about the startup related to the finances, which is one of the most ignored part, but very important part. I hope every student present here will definitely get the guidance, get the inputs. Those who want to become entrepreneurs or those who are at least having some idea in the mind that we want to implement this idea as a product or a service and serve to the society. So I hope towards the end of a session, whenever there is a question and answer session, students will ask the relevant doubt and hopefully this session would be fruitful for us. It's always a aim for us that we need to bring as many as good speaker for you people so that we can have a strong foundation and we can achieve the targets in the stipulated time. So we are waiting for the speaker. Within 2 minutes, speaker will join and we can start the session, guys.
A very good morning to all of you present here. Let's start our day with some entrepreneur mindset motivation. I'm extremely privileged to have the opportunity to address an amazing personality today. It's always an honor to be able to motivate young minds. Today's youth is the future of our state and country. Brilliant young entrepreneurs in making that I'm witnessing today in the audience will grow up to be the citizens of our beloved nation tomorrow. We have gathered here on Teams to hear Pradeep sir motivate and inspire us. On behalf of the PICT EDC team, I cordially and respectfully welcome Mr. Pradeep Dhake. He is the COO of AIC STPI Bangalore, supported by STPI and AIM Niti Aayog. He is currently handling responsibilities of AIC STPI Bengaluru, core incubation and innovation activities STPI Next project. He has funded projects in 5 years up to 120 lakhs and 4 funding project fetched and run. He has a total experience of 13 plus years. He also has been granted with an international patent for IoT based disaster management. Initiator of incubator at MIT Pune, made incubator policy. Successfully made AIC MIT incubator proposal from Niti Aayog. He's also been a mentor at ATL, AIM, Niti Aayog and 3 startups. Worked in MIT plus BlackBerry project CSR initiative that was in 2014, titled Find Missing Childs. He has also won Asia's biggest hackathon by Central Government of India project titled River Water Audit Management. Made tie-ups with MNRE, NISE Government of India for solar programs and fetched and coordinated with DST funding of 5 crore and 10.5 lakh under NIMAT project. He runs various skill development programs for encouraging entrepreneurship students. Let's get on to some achievements by Sir. He has been awarded with Dr. APJ Abdul Kalam Innovation Award by MIT WPU Pune, National Elevator for Smart India Hackathon, winner of Smart India Hackathon, Texas Institute Innovation Competition, and Nodal Officer Surya Mitra, supported by Ministry of RN, Government of India, to name a few. I also welcome Dr. Gaurav Bansod sir, head of EDC BIC SIC, Ranjit Bidwe sir, Bhushan Zope sir, coordinator EDC BIC SIC, Isha ma'am, and all other faculty who have joined and supported us in our endeavor to spread the light of true knowledge. Over to you, Pradeep sir.
Thank you, Mr. Sayyam. Thank you all, dear friends. I shall start my discussion with the concept and the various challenges of the technology, and thereafter we shall go for the overall TRL scale and the technology transfer related discussions. To start with, let me share my screen first. Do I have a presenter rights?
Yes, sir, you do have.
This is Microsoft. Is it visible?
Yes, sir.
Is it visible now? I made it in a full screen.
Yes, sir, it is.
Okay, fine. Me. Yeah. So the discussion starts with the title. As you know, it is a TRL and the tech transfer process. The TRL is a very, I would say, the important and the buzzword nowadays. Every innovation houses and the respective incubators are using this TRL scale to map the technology and to map the technology with the startup readiness. The TRL stands for the technology readiness level, and the TTP stands for technology transfer process. Usually the TRL we used to map with the product or the services, and the technology also we used to map with the product and the services, and thereafter eventually it is when we talk of the when we start discussing and when we start considering the commercialization part, at that time the actual concept of TTP come into picture with the ownership rights and the other litigations, if any, for the overall execution of that product, execution of the product service for the startup. To move ahead, so, so our discussion is based on the six points. First three is related to the TRL, and the next three is related to the TTP. In first three, we'll start with the intro of the TRL, and the one I'll be showing you one TRL tool also, wherein we can easily map the technology readiness level with the help of this tool. I shall share that tool to I shall demonstrate that tool to you, and thereafter we shall, as I said, we shall discuss about this TTP. But before we discuss about this TRL or the technology mapping or the TRL technology readiness, we need to understand first our current status of the technology and innovations in the pan India, I would say. Dear friends, you all are the engineering students from the very bright college named PICT. Uh, Everyone knows that we Indians are having a very good 5 qualities as far as this technology and innovations are concerned. One is we have a very good technical skill. Average, I'm saying everything is based on the scale of average. I'm saying more than average, we are very good at technical front. More than average, we are very good at the working attitude. Also, we are not lazy persons as the few of the other countries uh, technocrats are. Most important is our analytical skill and logical skill are comparatively good if you compare with the other worldwide scenario. Everyone knows that Indians and Israelis analytical and logical skills are very good. So obviously we have that edge point, and most important, we are very much sustainable. We are ready to adjust as per the environment. We are ready to adjust as per the situation. So this point is also very much important from the uh, technocrats or the engineers side. So we have such type of all 5 good qualities with us. But but on a contrary side, if you see on a technical front, or the, I would say, technology front, the worldwide fact says that techno-based ideas usually enter with the innovation factor of 5% only. Means out of 100 teams, only five ideas are having some novel innovations, or 5% of ideas having some novel technology convergence, I would say. Uh, Again, if you map with the sustainability part here, though we have a good sustainability skill, though we have a good analytical and logical skill, but if you see the worldwide scenario says that out of 10 ideas, only 2 ideas are going to sustain. That means it is very clearly from the mathematical calculation, out of 10, if 2 are going to sustain, means 8 are going to die. Now, why this is happening worldwide? The reason is very much clear, that it has a lack of awareness towards the technology mapping, the lack of awareness towards the incubators, and due to this technology mapping awareness and the incubators awareness overall, that means lack of awareness, I would say. overall overall result is that the innovation index is going to dampen or reduced. So this is the fact over here. So how to tackle with such type of issues? The one thing is that worldwide, if you see, the ideas are not going to sustain, ideas are going to die. Most and more on top of that, the very less ideas are coming towards the technology implementation, means new or novel technology implementation, like that. And we Indians can take that challenge as a scope of opportunity, I would say. So how we can do this? So we can do this by understanding the maturity of the technology. Friends, you are the engineering students, and engineering students always come up with the fresh minds, fresh ideas, with the fresh zeal and energy. So with that respect, it is very important to understand whatever the ideas we are putting on a table. Okay, we need to understand the maturity level of that idea, or maturity level of maturity level of technology behind that idea also. So, and here the concept of TRL, that is technology readiness scale, technology readiness level, come into the picture. So there is a need actually to measure the maturity of technology applied behind the product or idea. Once we come to know about the maturity of the technology behind the whichever idea is being proposed by the student or the faculty or by the respective college or the institute or the university, if we know the maturity of the technology, it is very easy for us also to implement that idea on a war front. And if we feel that there are some challenges in that technology based on the maturity, we can easily try to figure out what are the different challenges, and we can also try to figure out what are the different solutions for that. So TRL is, what is the TRL? The TRL is one kind of an I would say a platform wherein you can understand how to measure the technology, how to understand the maturity of the technology. So TRL is nothing but one kind of a scale to measure the technology maturity. Now again here again here, do we have that abilities initially? Yes, the answer is very clear. We have that ability to understand the maturity of technology also. Though a third year student of engineering or final year student of engineering had not actually work on the industry standards of the technology, but still mapping of the technology is very easy once you know the basic rules of the TRL scale. Okay, in that case, it is very easy to scale up the technology mapping with the actual outcome or output, I would say. So we have that ability. Indians obviously have that ability. So this technology readiness level mapped in total 9 stages. Start with the TRL, 10 stages. Start with the TRL 0 to TRL 9. TRL 0 starts with the idea, and the last TRL 9 end with the actual commercialization of an application, which may be resulted into the business. So TRL 0, as name said, it is completely belongs to the idea. The idea may be unproven concept. No testing has been performed till date for that idea. It is just an hypothetical idea, which usually we used to talk in a canteen. We used to talk in a hostels or in front of our supervisors or the professors. We have that idea. We used to chit chat. We used to do the even gossips also based on the ideas. Okay, so that idea stage is nothing but the TRL 0. Which is unproven. We don't know whether it is feasible or not, whether it is proven or not, but still we are discussing, because this has been come from the young mind. This has been come from the respective technocrat, maybe obviously you or the professors or the respective supervisors or the respective institute also. So the next stage of the technology readiness level is the basic research. Once you feel that okay, this idea is really having some potential, let's try out some basic research out of it. So the principles postulated and observed but not experimental proof is available. So when you discuss this with your teachers, with your professor, the professor at a blind stage, he can say, okay, such type of idea is a kind of unfeasible one, but we need to check on a lab experiment with the lab experiment, or we need to check with the prototype experiment for that. So if your respective mentor or the professor is saying that yes, this idea is having some backup of the basic research or the basic evidence of the proof, which is not at all tested or validated from your end, but in recent past it is available. In that case, we can map this to the TRL1. Dear friend, I forget to mention one point over here, though I'll be discussing these points with you, but I'm going to cover this entire discussion within 45 minutes, and later on I would be very happy to take your question, because these are the such topic wherein lots of questions if I get from your side, I would be very happy to answer, because otherwise this will be a kind of an one-way traffic of discussion or a lecture, I would say, which I don't want to execute over here. So I'll wrap up this entire things in 45 minutes, and then I would be happy to take the questions. Though it is a silly question or the mature question, it doesn't matter, but the questions are most important, and more questions are always welcome. The third stage is TRL2, that is a technology formulation. It starts with the concept and the application have been formulated. Yes, in that case, your partner or maybe your mentor or your professor or maybe some R&D houses, if they do some formulation on that idea or that concept, in that case, you can keep this stage into TRL2. Similarly, TRL3, it is related to the applied research. So whatever the basic research you have, if you are going to apply the same basic research on your idea, and if you are observing the results out of it, then this stage of the technology called as a TRL3, which is now here till TRL0 to 2, it can be considered under the ideation stage only. But since TRL3 to, I would say, 6, it would be considered into the prototyping stage, or the technology maturity belongs to prototyping here, or the at least lab prototyping. So applied research, when you apply the actual basic research on your idea, and if you try to find out the results, then it is considered as a proof of concept. Generally, the final year engineering student or third year engineering student, whatever the project they do, they either fall in the TRL3 or the TRL4, because whatever the basic research have been done in recent past, they are going to apply this on their respective problem statement, and then this problem statement is converted into proof of concept or the working prototype or the ugly prototype, I would say. Now, the TRL4 is called as a small scale prototype, built in a laboratory environment like a engineering college, like R&D houses, like innovation houses, like that, or the incubator labs also. So small scale prototype. So here we are coming up with actual proof of concept or the ugly prototype. We can say it as a beta prototype. Then the TRL5, once you complete with the prototype, let us map this example with the final year engineering project. When you come up with the working model of your final year engineering project or third year engineering mini project, okay, then in that case it is TRL till it is the stage will be considered as a TRL4 for that. Now, when you want to expand or escalate this prototype to the larger or the intended environment, okay, in that case the TRL5 come into the picture. It is called as a large scale prototype, which is going to tested in an intended environment. Now, what is intended environment? Intended environment is the actual real-time environment or real-time situation. For example, suppose any final year or third year students have come up with the robot application he has made, but he has tested that robot application in the laboratory and consider that robot is I would say it is a pick and place on a off-road condition, or pick and place of the object in off-road conditions. So what in TRL5 what we can do, we can actually place that robot application in on off-road, and on off-road we'll put some objects over there, actual objects whichever is available, and in that intended environment, the typical real-time environment, we are going to test whether our project or our prototype is working or not. In that case, we'll come to know whether our whatever the technology we have applied behind this project or the prototype, okay, which this is actually working or not. So this is a TRL5. Next one is a prototype system based on this large scale prototype. Once it is completed or succeed, then the TRL6 come into picture, wherein the whatever the tested environment prototype you have, we'll be closing this with the expected performance. We are going to map this with the expected performance. Means, for example, let us say the same pick and place robotic application is performing as per the desired expectation or not, or the desired milestones or not. And if it is if it is not working, then we'll still again put this under TRL 5, and if it is working, then it will be in TRL 6. Thereafter, we can go ahead with the actual demonstration on a operational environment at pre-commercial scale. So what we can do, we can share this robotic application to 500 clients, I would say 500 people, and we'll ask that these are the 500. We'll ask to these 500 people that you use this robotic application, robotic product or robotic application at your end, in your environment, whichever you have, whichever is available with you, and you give us the critics or give us the critical feedback so that we can again revise if any of the challenges or the lacunas coming up. Next one, once we get the feedback from this 500 clients, or I would say 500 people, then the TRL's 8, and if everything is okay with this 500 feedback, then the TRL 8 come into picture. It is called as a first commercial kind of a system, and here whatever the feedback we have received from these 500 people, maybe whether it is a software related feedback or hardware related feedback, whatever the challenges and the issues they have experienced, okay, we can fix up these all challenges and issues, and we can actually start for the manufacturing of the product. Now here the project is converted, or prototype is converted into product, and this TRL 8 is called as a product. And here the birth of startup may come into picture if the respective innovator team would like to actually kick off the product on a commercial front. Now here, if all the manufacturing related issues has been solved in a real-time environment, then the full commercial application is ready for the consumers, for the clients, and they can go ahead. So at a nutshell, if you see, friends, how you can measure the technology readiness level is typically categorized on 4 departments, I would say, or the clusters, I would say. As I said, first 0 to 3, first 4 categories come in, always considered into ideation stage. Later on, the 4th and 5th category considered into prototyping stage, and whatever the prototype we have developed, the validation we can do in the intended environment and the pre-commercial scale operational environment. Later on, the actual startup related product we can consider into stage 8 and stage 9. Stage 9 is actually the mature product, wherein you can actually sell that product from your startup side or maybe from your engineering college side, like that. Now, whatever these theoretical discussions I have done, let's have some demonstration also. So there is one calculator to measure the TRL over here. Is it visible? Is this calculator visible?
Yeah, the slide TRL Calculator Demo, that slide is visible.
No, not slide. This tool I have opened, is it visible?
No. Sir, have you just shared the PPT screen while sharing?
Maybe, yes. I need to share the screen instead of that PPT screen.
Yes.
Just give me a minute.
Yes, sir, sure.
Is it visible now?
Yes, sir, it is.
Okay. So, dear friends, this is a technology and commercialization readiness level calculator. I have not developed this one. This has been developed by New York State of Opportunity. It is one kind of an organization or the consortium, I would say, based out at New York. They have developed this tool to map how the technology, what is the stage of technology, and how we can map with the actual maturity of that maturity based on the TRL scale. So this is a very simple tool developed in Excel itself, Excel application itself, MS Excel. Let us say now To give the demonstration, may I take any example from your side? If any final year engineering student is there, if he or she can tell me the project details, I can type or I can feed over here in real time, and the results we can get over here automatically. So I would be happy to give the real actual example. Anyone can share his project stage or project details to me, whether it is software or hardware, it doesn't matter. If it is in prototyping stage or some working prototype, if you have developed, please tell me. Anyone? Okay, I'll give a dummy example. You can correlate this with your existing project also. Let us take there is one innovator team. Let us say PICT 1. Okay, so this PICT team 1 is working on some product or some idea. Let us say that, as I said, a robotic application. So what is this robotic application all about? This robotic application is pick and place, I would say. A simple application we can consider. Now, this is a team 1. Now, we'll ask some questions to that team 1 to tell us the exact status based on few points over here. Consider from the technology side, whether the project, the pick and place robotic application project work is beyond the basic research and the technology concept has been defined, or whether the applied research has begun and practical applications have been identified, or whether this robotic application preliminary testing and the testing of technology components has been started and technical feasibility has been established in a laboratory environment. Similarly, the initial testing has been done in the laboratory environment and the laboratory scale with the intended application in the intended environment have been done. So consider initially that let us say initial testing has been done, means a robotic application is ready now, but it has been tested in the laboratory environment only. So just click this laboratory environment. So we have recorded this answer automatically over here. Now come to this is about the technology. Now come to the product. The initial product or the market fit has been defined, or if the robotic application pilot scale product system has been tested in an intended application, the demonstration of full scale product has been done, or the actual product has been proven to work in the near final form under the respective set of expected condition. It is called as a real-time environment, I would say. This fourth point is nothing but the real-time environment. Next one is the product system is a final form and has been operated under the full range of operating. Means this is an actual industry environment, I would say. So consider this robotic application is at initial product market fit has been defined, and let us say consider it is under market fit. Initial product fit or the market fit has been defined, only defined. We have not tested, we have only defined that as per the market objectives or the market expectation. We have decided few points and few, I would say, some conditions for the robotic application. Next one is based on the product, the product definition and design. It is called of now here again 5 points are there. The one or more initial product hypothesis have been defined, mapping of product with the attribute design, customer needs. Now here again we consider let us say mapping of product or the system against the customer need has highlighted a clear value proposition. Means we know the clear value proposition, means where we are going to use, whether we are going to use this robotic pick and place at let us say Parvati area of Pune. Okay, wherein after a rainy season there are lots of garbage used to accumulate over there, and if we use this robotic application over there, so we know the value proposition. See, it has some value. If we use this, the value proposition we know about this, though we have not tested it, but the value proposition we have identified. So we have mapped this map with the value proposition. It is very clear. Now next one is that the competitive landscape. consider the secondary market research has been performed and the basic knowledge of the potential application landscape have been identified. I would say here we have not tested in a real-time environment, so we do not know the actual competition. I'm not saying competition in terms of clients or in competition in terms of a company, competition in terms of challenges also. But still, we don't know because we have not tested this in a real-time environment. So what are the different competitional challenges we will be facing? We do not know, but we have identified that there are some challenges. So, for example, we'll use this first point only. And most important is team. Here, remember friends, in technology readiness level, the team is also equally important. Who is going to handle, who is going to implement this product, or who is behind the implementation of this product. So the team is the actual I would say category wherein the equal points have been given, equal scaling have been given. So consider the no team or the company in place. There is no team. सिर्फ कोई तो प्रोफेसर ने बोला है और किसी फ्रेंड ने बोला इसलिए टेस्ट कर रहे हैं, but there is no team. Or if a solely technical or non-technical founder is running the company with no outside assistant, or there is an incubation support is there for this team, or a balanced technical business development and commercialization experience is there, means here the advisor mentors have have connected with the team, and the team has registered the company also, and the balanced team with the all capabilities of onboard, like means in that team the expertise of sales, marketing, customer service, operations, technology operations, or the business operations, everything, every expertise is available with the team combination. So here we'll consider our robotic application is with solely technical, right? Consider you as an engineering student, so you consider yourself as a technical student, but there is no outside assistance, means you are doing by your own in your college environment. Next one is the go-to-market strategy. So consider, as we have not tested in a real-time environment, so consider this into initial business model only. We have done with the initial business model, but rest of the parts is yet to complete. Now there is one again the futuristic question that if you come up with the manufacturing standard product, in that case how you are going to manage the supply chain. So in that case the potential suppliers and the customers have been identified and mapped. Yes, this is a theoretical literature survey. We can say that where our robotic application is going to use. So we have identified the suppliers, customers, partners with whom we can collaboratively work, and this is our supply chain strategy. So consider this is the first, because these are the very mature stages of the product, but this one is for the prototyping stages, which generally every team member can easily do. So these are the stage of our current prototype. Consider against this technology mapping, we have answered, we have selected the status of our project, status of our I would say product. Now, once we complete this, let's move to summary and results. This is a PICT team 1. I'll just convert it into a PDF so that it will be easy to understand. Now, see here. This PDF has been generated. The PICT team 1 proposal or the product was the robotic application. Description, as I said. Now here is technology readiness level is 4. Why it is 4? Because we have not tested this in a real-time environment. We have tested this in a only laboratory environment. Plus the commercialization readiness level is 1. Here it is an added one. To understand even if you come up with the product, then whether it is going to sell or not, and if you want to sell this product, then what is the actual maturity level of the commercialization. So commercialization maturity level is 1. Why? Because here under GTM category, go to market category, only business model we have jot down on a paper, on a table, but actual strategy of commercialization we have not tested. We have not shared this with the 500 people. We have not taken any feedback from that 500 people like that. or we have not shared this with even your department or college students for the testing, and they have not given any feedback to us. So that's why the commercialization point of view, the commercialization maturity is 1, but the technology maturity is 4. So what does it mean here? If you see the spider chart over here, where you have to work is you have to work on a team, because in your team you need experts who can take care of the commercials part, sales and marketing, and most important the validation part, because validation is missing over here. Next one is for go to market. Obviously it is almost near to 0. So whatever the business model you have made, if you can work upon this business model, then maybe it can reach to point 2 or 3, means score of 2 or 3. Thereafter, this marketing and supply chain, obviously you do not have the team of sales and marketing or the business development. That's why the supply chain you have not identified. But later on, whichever the partners and the suppliers on a paper, you can actually start discussing with these suppliers and partners, and you can go ahead with this. You can go ahead with the scaling of the manufacturing and supply chain. Manufacturing and supply chain. Technology, yes, technology is comparatively okay. The prototype is ready at your end, which is at lab environment. Now start working for the intended environment. Product is obviously not developed because you have not tested your product, your project in a intended environment, and you have not taken any feedback from the minimum 500, I would say, critics or the 500 people. Product definition and design, it is okay. These are the interdependent. Once you develop the product definition and design is automatically going to increase. And the competitive landscape is 0 because we have not taken any feedback from the outside market. So such type of technology maturity you can easily map, and when you share this with you among your team member, then you will come to know where you are lagging and where you are what are your strength point and what are your weak points, and accordingly you can easily work upon it. Now moving ahead, now once you know that this is my stage is at my product stage is at prototyping stage or maybe validation stage, then easily here what happened now, friends, you come to know where your product is stuck now, and immediately once you know the problem, you can easily find out the solutions also, and accordingly based on this technology readiness result, you can try to figure out the probable solutions for that. Now moving ahead, consider there is one application who is fully commercial in mode now, means I'm talking about the stage 9. Then the concept of technology transfer process starts. Now, what is this technology transfer process? I'll tell you. Now, this is typically for the startups and product both, not for the prototype, not for the ideation stage. Now, when we talk of this technology, there are basically three technologies worldwide. This is the category of technology, I would say. One is the emerging technology, one is the innovative technology, and one is the established technology. In case of emerging technology, as name implies, it is just an emerging. There is no hard and thumb rule to justify that this technology having this type of outcomes and all. For example, the blockchain, I would say blockchain technology is, I would say, very till 2 years ago it was emerging, but nowadays it is a innovative technology, because before COVID or before until 2019, I would say it was considered under the emerging one, because there is currently it is undergoing with the bench scale testing, which has the small version of the technology in the laboratory environment and all. But nowadays, if you see under NFT or under, I would say, metaverse, everyone is using the blockchain concept. So it is a innovative. So they have not tested under the laboratory environment. They have tested in an intended environment, isn't it? So that's why it is innovative technology. And established technology is, I would say, automotive technology, the four-wheelers, IC engine, I would say, petrol engine or diesel engine. So IC engine is the technology which is established in nature. But in case of EV means electric vehicle, this is an innovative technology. Whereas the IC engine for the petrol or diesel is a established technology. So these are the major three categories of technology. Now, once you have the technology into commercial mode, then the concept of technology transfer becomes really important. Now, technology transfer, TTP or technology transfer means what? Actually, it is a process by which the existing knowledge or the facility or the capability developed under the R&D stage are utilized to fulfill the public and private need. See, friends, when you do the project and when you convert that project into product, there is no sense to use make this product stage into your library files. Instead of that, we have to come out from that library stage and we have to make sure for the overall actual commercial utilization of that product. And for that purpose, if we can fulfill the need of the public and the private organization or the private stakeholders, that would be very great. So technology transfer include range of, I need to full screen this. The technology transfer includes a range of formal and informal cooperation between technology developers and the technology seeker. Here, technology seeker means a client or the consumer, I would say, who's going to use this. So if you see the World Intellectual Property Organization says that defines the TTP or the technology transfer as the transfer of new technologies from universities to the research institute to the parties capable of commercialization. Means whatever the robotic application we were talking about, once you complete this robotic application in a product stage, in that case, you can easily discuss with the respective robotic industries who are already working in that area, and you can have the partnership or the collaboration with them, and you can also start your own business, being a tier 1, tier 2 business, I would say, with that OEMs or with that large scale industries. You can easily collaborate and you can start. So here when you collaborate with the big fish or the big organization or the big industries, in that case, it is very important to have the clear and the legal way of the technology sharing and the technology transfer. So in the sense of transfer of technology across the international borders, generally from the developed to the developing country. Usually this is an hypothetical kind of a rule that usually developed countries used to share the technologies with the developing countries. Like as you said, very recently we got that some defense related equipments from the developed countries like US, like I would say Russia, like France, and we have got this. So because it was our need, so that's why they have shared the technology with us under some conditions also. Similarly, we being a software, I would say our strength is software. Okay, so when we share our software applications to the other countries, in that case, while sharing this technology of the software, we also have some terms and conditions under the TTP, that is technology transfer process. So generally, technology transfer consists of basically the knowledge transfer and the IP rights, which includes as I said, the intellectual property, then the subject of formal consulting and training agreements. Now, this is most important actually, formal consulting agreement and training agreement. Then the communicating with the workplace or the research setting, whichever is available at customer end or the consumer end. And the diffused by the publication or other means. So as far as the publications are concerned, it has some restrictions also. Now, if you see the overall concept of this TTP, it starts with the mandatory disclosure, starts with the NDA, that is called the non-disclosure agreement in form of an idea. Then we can have the patent, then we can have the agreement for the administration of that technology, and then we can give the license. The best example, dear friends, is I would say the Microsoft application. Microsoft application has an agreement with the respective client. When you buy that Microsoft product, it is one kind of an administrative agreement wherein the certain features are allowed to use by the respective client, but there are certain features which you cannot use for, which you can use for the personal use, but you cannot use for the commercial use. So that licensing has been given, and most important, the ownership is still with the Microsoft, not with you. For example, this PPT application, PowerPoint application, we are allowed to use this PowerPoint application, but the ownership of this PowerPoint as a technology still lies with the respective organization of this application, that is Microsoft. So based on that, this disclosure with the idea, then the patenting, and most important, this is called as an administrative agreement. this and the licensing agreement. So in TTP, these two, actually these all three are equally important, but from commercial point of view, these two are most important. So commercialization refers to all these three horizontals: patent, agreement administration, and the licensing, so that you can get more and more royalties out of it. So, for example, Microsoft is getting royalty, Intel is getting royalty, isn't it? Even if your laptop is, let us say, Dell laptop or Lenovo laptop, but the microprocessor belongs to the Intel, isn't it? So whenever the Lenovo or the Dell, they are using the microprocessor, the royalty goes to the respective Intel company only. Similarly, this is called as a part of technology transfer process. So this commercialization and the royalty comprises with this three part, that is patent, agreement, administration, and the licensing. I'm not going in depth of these horizontals, because you being an engineering students, initially this much of information is, I feel, very informative for you, because it has lots of techno-commercial languages involved in this agreement, administration, and licensing. In maybe in some other lecture or some other discussion, I'll be happy to discuss how the techno-legal and techno-commercial language or the format we can use this use along with this patent and the agreement, administration, and the licensing. Yeah. So if you see the overall chart, it starts with the promotion of your products, then the overall innovation we can do over that promotion. Then we do some R&D again on that product or the project. Then we can do some validation and the assessment. This assessment is done by the minimum 500 people, as I told. Then whatever the information and feedback we are getting, we can get it. And then we ask the respective collaborator to invest in our idea, invest in our product, so that we can share this for the actual commercialization. So investment and the collaboration leading to commercialization. And this entire process is again mapping with the TRL, that is technology readiness level of the TTP. So what we can do is we can start with the basic research of the TRL, then proper paperwork we can do, patenting and the agreement of commercialization, everything we can do under TTP. Then we can fix up the pricing also. What are the unit economics and what are the different financial traction we can fix up in the pricing. Then what part can be published, what cannot be published, that all terms and conditions we can put under the publicity norm. Then the partnership engagements, do's and don'ts of partnership we can put up, and the overall market acceptance we can do when we actually hand over the product to the customer or hand over this product to the respective other third party organization. So these are the various content of technology transfer. So TTP involve the reference to the skill, knowledge, technologies, methods of manufacturing, sample of manufacturing, and facilities is probably wide enough to refer the subject of transfer. But now again, this transfer can be usually in between the public universities and the government research institute and the private universities, private industries. Then it can be in between the research R&D houses and the other departments of the single business. This TTP can be in between, can be in between the various entities or the branches of the business group in franchising operations from the franchisor or the franchises, any one kind of the case. It can be between the international organization and the national organization, that is also possible. It can be in between the industrialized economics and the developing economics. So with this, there are again two approach of the TTP come. One is the technology push and one is the market push. So what is technology push? The example is very easy. The innovator sees an opportunity to profit from the technology that has little or no current market. It is an entirely new market, I would say, is created based on the novel capacities of the technology. Dear friends, you might have heard about the Facebook has been renamed to the Meta. And they are coming up with they have adopted the metaverse technology. Right now, the very few people knows about the metaverse, but the company used this category of technology push. Now they are pushing this metaverse to the end users, to the public, so that the users don't know what it is. But once it is available for the user, people wants it. Yeah, dear friends, Apple used the similar philosophy because people don't know what are the features of Apple, but once they know the features of Apple, they feel that I should use this feature, and that's why they are buying the Apple products. So they're using the concept of technology push over here. Similarly, there is one more concept called market push. Here, the market pulls the technology into it. Means customer are saying that we need this technology, we need this solution, and based on that only the respective industrialist or the startups or the idea innovators are working and they are giving the solution. For example, I would say the medical technology. Medical technology needs right now need augmented reality or the artificial intelligence. Means they need some solution based on the AR, VR, and the artificial intelligence, and that's why most of the companies are working on that medical technologies. And it is considered under market push because market needs the solution. That's why the companies are working on that. So based on that, there are various roles. Last two slides are there. Various roles and the sectors are there. Idea, then you do the research, then you can do the development, then go for the manufacture, the production and the manufacture, and then you can go for the distribution. And who can do this research and development? Startup firms can do the research and development. R&D firms also can do the research and development. Universities also can contribute to the research and development over here. Then the actual when the product is developed, then for the mass production or the mass manufacturing, the larger companies come into picture. For example, I'll tell you the Apple technology or the Apple product is developed, but where it is going to manufacture, they are going to manufacture in China and the Israel, because they want the large mass production or the mass manufacturing, and the overall mass manufacturing setup is available with China and Israel. Similarly, now India is also coming up with the mass production platforms and mass production floors, so that the technology can be implemented in India itself, implemented and produced or manufactured in India itself. So large companies are taking care of this mass production or the mass manufacturing and the distribution also. But as far as this development of product is concerned or the research behind the product is concerned, startup, R&D firm and universities can take a major or the vital role for this technology. Sorry. So there are different ways by which the technology can be transferred. It can be done by the consulting, just on consulting. It can be with the graduating students, means university can ask the industry that this technology is been developed by us and the respective students are working on that. And once they graduate, you have to appoint them as an employee so that they will also get some opportunity of the job and you will also get the solutions out of it. So it considered under moving heads, means graduating student can be sent to the directly industry if the industry wants that technology or wants that product. Then the faculty moving on. Sometime it may happen that the faculty for some sabbatical leave or some temporary deputation, they can go to industries and they can work for that industry. Collaborative research, we can transfer the technology using collaborative research, means your college and the industry can work collaboratively on the respective product development and they can do. Patenting and licensing means you complete the product and do the patent and you sell that patent under the TTP procedure. That is also possible. Service and outreach as a part of extension, and there are some spin-off of companies who are ready to take up your product for the mass production or for the overall development. So this is also possible. So by this all ways you can transfer the knowledge, you can transfer the technology or the product to the respective stakeholders. So what are the units of the technology transfer? R&D units. University also can establish the TTP unit, public research centers, technology institutes. Then the company units, supplier of technology and R&D to third parties, spin-offs and the startups and the large R&D departments and the competitors like that. Yeah. So this was from my side, dear friends. I'm Pradeep Dage. I feel that everyone has listened this discussion and I'm very happy to take the questions from your side.
Thank you so much, sir. If anybody has any questions for sir to address, please raise your hands and we can go ahead with the questions. Okay, sir, I have a few questions. Till then, if anybody is interested to ask, they may go ahead. My first question to you is, Students come up with amazing ideas or even great motivation to directly convert their ideas into startups. Maybe they'll buy domains and deploy their apps or whatever. But then, what are the few things that students miss out on? We'd be glad to hear your own experiences regarding this.
As far as software applications are concerned, once you initially, if I'm not wrong, you starts with the wireframing or the mockup. Then you actually do the coding and you come up with the beta version of your application. But the next thing is that only application is working as per the intended events. That doesn't mean your application is mature. What you have to do is you have to test this application in a, as I said, real-time environment. You have to distribute this app to at least 10 people initially. You can ask them to work upon this. You use this for 1 day or 2 day or 3 day and give us the critical feedback so that they can give you the feedback, and based on their feedback you can actually work upon whether the UI is good or not and what are the different testing challenges, what are the different event challenges they are facing during the transactions of any kind of an activity like that. Similarly you can work upon, and later on most important that you must focus on the overall load testing of the application.
Right.
Load testing or stress testing, which generally the engineering student forget to do. If you really want to come up with the stable application, then you have to test it. You have to perform the load testing for that, stress testing for that, and you have to check whether the intended ramp up time or the intended users activity, whether our application is stable or not, and if it is not stable, then at what event he is going to crash. So that crash event also you need to record in your logs so that you will come to know to make this application stable, what are the different things which I have to perform. And once you complete this load testing, then I would suggest that you are all using the social media. You put your application link on a social media. You ask them to use and give us the critical feedback. And based on that, now this is called as actual pre-sale, I would say, pre-sale stage of your product. And based on that feedback, you will come to know. However, if you have any kind of an reservations while sharing the app or the application, what you can do, you can copyright it. If there is a process algorithm behind the application, then you can initially patent it, isn't it? So likewise, you can go ahead.
Right. Perfectly addressed. Thank you, sir. Sir, you are known for your product development skills. So what is the actual importance of this for incubation of any startup?
I'm not getting your point. Can you elaborate your question?
Yeah. So I mean to say, you have been training students in sessions and programs for product development on any product or any startup, any idea that is to be incubated. So what is the actual importance if students miss out on that product development stage? So what will they face in future?
Now, see, initially, as I said, if your product or your project is in idea stage, see, while doing this project, you always have to have this TRL chart in front of you, which will alarm you that your stage is at TRL 0 or TRL 1 or TRL 2, and if you're not crossing that stage, that means there is some problem, or maybe some efforts are missing. And what are those efforts? Which efforts you are missing? If you would like to discuss this in that case, what you have to do is you have to share your current work with your mentors, with your professors, and you have to take some ideas how to improve these products. See, in today's world, single person cannot do everything.
Right.
We being an engineering student or engineering candidate, we can think of this technology very clearly, but we do not know the usage of the technology. So for that purpose, in today's era, we have to share our concerns and the work with the others with whom we trust. Actually, obviously, we trust. So you can discuss with your professors, you can discuss with your head of incubation also. You can discuss with your principal, or I would say what I would suggest is that if you have an incubator, I do not know whether it is or not, but in that incubator you fix up one Friday meet. This is just a thought I'm passing.
Right.
You ask the like-minded student teams to come to gather on maybe a Friday or any of the day, and just to discuss casually on the technological challenges. So what is happening here near around? Take the example. So what happens? This group discussion shall help you to understand what are your strength of the thinking and what are the weaknesses which you have to explore for the improvement of the I would say the respective lacunas. And obviously, if in that case, if anyone would like to share that I'm facing this type of XYZ problem, do you have any approach to share? So likewise, you can share. If possible, you can ask your professors also to join the discussion. And it is not necessary that the professor, whatever the professor is saying to you, that immediately you have to work upon it. If you feel the professor's approach is obviously in form of testing side, then you can test. But if it is not in commercial, if it is not in a feasible way, then in that case you have to work upon the professor's suggestion to understand how this can be a feasible. And for that purpose, again, you have to be in touch with that professor. Sir, you said about this idea, this approach, but I feel this is from feasibility point of view, I'm facing these challenges. So do you have any option for that? If professor feel okay, he has some solution, then obviously he will be happy to share you. But if he feel that okay, for this I do not have any solution, but in that case at least professor will come to know that whatever approach he is saying, this is the probable challenge behind that idea, and he may share to his network also. Then he may discuss with some his colleagues. अच्छा, मैंने तो ये आइडिया बताया था, ये अच्छा भी था, लेकिन अच्छा मेरे स्टूडेंट ने इसके ऊपर काम करने के बाद ये चैलेंज वहां पे आया है, अब इसके लिए क्या? So likewise you have to do. So the more you share, the more you get in today's age. And for that purpose, there are some paperwork is also there when you're actually sharing some technical stuffs. In that case, you can do some NDA, you can do some copyrights or IP. Likewise, you can go ahead.
Agreed. Appreciate the Friday meet point. I really like that. Next question is from a student. He has shared the question with me. Patenting process in India is bit slow due to that when patent. Okay. Sorry for the disturbance. Patenting process in India is bit slow due to that when patent grants, the patented technology has already advanced. So what's your view on that?
I don't think nowadays the patenting procedure is slow. It was slow, but if you have a product with you, working prototype with you, you can directly file to the complete mode of application instead of provisional application. And after that, immediately within a month, your patent is going to publish. Once it is published, you can directly ask for the examination also. And if everything goes okay within a year, obviously within a year you will be getting the patent. But in that case, you have to register your startup with some incubator first. Then within a year, you can get the grant of the patent. If you do not have the startup registered with the incubator, then it will take some time, I agree. But I think within 2.5 years, you'll get the grant.
Right.
As far as copyright is concerned, it is again comparatively faster. For software applications, you can copyright also, and within 6 months, you can get the copyright.
Right.
For that purpose, there is no compulsion of the startup and all. Within 6 months, individual also can get the copyright.
Right. There's a next question in the chat by Chitranjan. Can innovators do a good business as innovator? always goes for advancement of his product. So sometimes he adds too much features and lags on business side. What are your views on that?
That's why you have to share and take the critics from the open market,
Mm-hmm.
because we feel that it has lots of challenges, or we feel that it has no challenges. But when you share your application or share your work with someone, in that case, based on that critics, you'll come to know the various scope of improvement. And once you see, friends, once you know the scope of improvement and the challenges now, then the solution is just a matter of work only. So you can easily develop the solution, because already work on the idea, you are already come up with the prototype. Then just what you have to do, you have to just fix up that challenges, fix up that bugs, or I would say from software language, I would say what you have to do is you have to fix that bugs. That's it. And
Right.
it is very easy.
Yep. Okay. Sir, you have taken many skill development and entrepreneurship awareness programs for students, and you have arranged many cohorts for them and continue to do so. So, forgive me for asking a big want, but I take this opportunity to ask, can we have a specialized entrepreneurship cohort arranged by Niti Aayog under your leadership for PICT?
At individual level, I can certainly say yes. You discuss with your innovation and incubator head for that. We can launch this program, no problem, at individual level. As far as government is concerned, I cannot comment, but because this is in between organization to organization, not at individual level. And
Right.
what you have to do is you have to file the proposals for that. And proposal, a student cannot file. This is a condition. The institute need to file.
Right. Yeah, of course. We'll file the proposal through institute. We'll discuss with sir and all the other team members. Also, the last question: what are different opportunities given by Niti Aayog or AICT or Government of India as a whole for budding entrepreneurs?
There
Maybe
are lots
some
of opportunities
competitions.
are there. It is very big. The answer of this question is very elaborative in nature. There are hundreds of opportunities are there. I need to take a separate session for that. I have some funding opportunities are there. Some technological assistant opportunities are there. Some collab opportunities are there.
Mm-hmm.
Not only from government, from the private player also. They are giving some license, free tools, free license, some technology implementation platforms. Also, they are giving from private players. So it is a separate session actually. But yes, to start with, Niti Aayog is also giving lots of putting lots of efforts on incubation establishment, prototype development also. Uh, Thereafter, there are lots of other incubators are there, or organization who are very seriously working on the project to product and product to startup, this kind of a theme. And I think you all being a student, you must join such type of activity for that. I cannot enlist each and every scheme or each and every initiatives of the organization, government organization right now, because it will take a lot of time. Uh, I have a separate PPT also for that. But let's have a discussions in some other day. Or
Perfect.
in
Perfect.
offline, we can discuss. If you have any kind of an query or assistant, in offline, we can have the discussion for that.
Yes, sir. For sure. For sure. Thank you so much, Pradeep, sir.
However, one point I missed out is if any of the student would like to start the startup, or you would like to work upon the product, then currently I have launched one cohort program called Open Challenge Program, named is Open Challenge Program 2.0. Uh, I shall share you the link also. You must visit, and if anyone is having some idea, you can apply over here. If you get selected, then you will be onboarded as a ideation startup, and along with some some provision of seed funding also. I shall share you that link. Give me some time. Where it is? Yeah. So this one is. Can I close that. So this is the call for application under OCP, that is Open Challenge Program. And this is the link. What I can do is, do we have a chat box here?
Yes, sir, we do have.
How can I drop it? Achha.
Yes.
So I've just dropped here.
Yep.
So you can visit over here, and based on the category of the idea, if you want, you can apply here. What I need to do is how to stop the sharing. Yeah.
Yeah. Thank you for addressing all the questions, sir, and for boosting our morning on how to convert ideas and products into actual startup models. We are grateful to you, and you have always been an asset to our PICT EDC family. Lastly and importantly, I would like to thank all the people in the audience who are an integral part of this session. Uh, Thank you for your kind cooperation throughout the program and making making it a grand success.